Part 2. We are going to continue our lecture with considering classification of organic reactions, reagents, and reactivity of organic molecules. Classification of organic reactions. A typical chemical reaction requires a set of reagents. Substrates are reagents that contain a carbon atom. Products are substances that result from the reaction of the substrate with other reagents. There are two categories of products, the product of interest and the byproducts. The product of interest is the compound formed from the substrate. In the case of multi-stage process, some steps include the formation of intermediates that are unstable intermediate species. Organic radicals or ions are often intermediates. When writing a chemical equation, organic chemists write a transformation. A transformation includes the substrate, the other reagents, and the products. It assumes both the byproducts and coefficients. Classification of chemical reactions based on the idea of their mechanism is the most used in organic chemistry. Type of chemical bond cleavage, intermediates, nature of reagents, and other factors are taken into consideration. In accordance with the type of a chemical bond cleavage, reactions are divided into homolytic, symmetrical cleavage of a two-electron covalent bond to form two free radicals; heterolytic, asymmetrical breaking of a chemical bond leading to the formation of two particles with opposite charges; and pericyclic, molecular ones. Reactions can be ionic and radical ones by the nature of the intermediates. Ionic reactions are carried out with the participation of the charged particles. Intermediates of many organic reactions are carbocations and carbanions, resulting from the heterolytic cleavage of the starting materials. Carbocations are organic cations comprising a positively charged carbon atom. A carbon atom carrying a positive charge in a carbocation is in the sp2 hybridization state. Its sigma bonds are arranged in one plane, and the p orbital is vacant. Carbanions are organic anions containing a negatively charged carbon atom, trivalent carbon atom with a lone pair of electrons. Radical reactions occur involving free radicals. Free radicals are uncharged particles containing an unpaired electron, one electron atomic orbitals. Simple alkyl radicals have a flat structure. An unpaired electron is located on the p atomic orbital. Tertiary alkyl radicals have a tetrahedral structure. An unpaired electron occupies the sp3 hybridized orbitals. Pericyclic reactions occur without the formation of intermediate active particles. Simultaneous breaking of the old and the formation of new chemical bonds occur in reactions of this type. Ionic reactions are divided into the nucleophilic and electrophilic ones, depending on the nature of the reagent. Nucleophilic reagents donate an electron pair to form a chemical bond with the substrate. Nucleophilic reagents include molecules that contain at least one lone pair of electrons, ions carrying a negative charge, and molecules possessing centers with increased electron density. A nucleophilic reagent reacts with an electron-poor substrate. Electrophilic reagents accept an electron pair from the substrate during the formation of the chemical bond. Electrophilic reagents include cations, neutral molecules having a vacant orbital, or centers with the reduced electron density, and halogens in the presence of a Lewis acid. Electrophilic reagents are capable of forming a covalent bond with the substrate at taken centers with the increased electron density in the molecule. All organic reactions can be classified as substitution, addition, or elimination reactions. Each of these categories has a number of different reaction mechanisms. In a substitution reaction, an incoming atom or a group of atoms replaces a living atom or a group of atoms. In an addition reaction, pairs of atoms or groups of atoms are added to a multiple bond. In an elimination reaction, a pair of atoms or group of atoms leaves the substrate. The substrate then forms a multiple bond or forms a cyclic structure. Addition, elimination, and substitution reactions can proceed through a nucleophilic or electrophilic mechanism. Acidity and basicity of organic compounds. Most organic reactions can be categorized as acid-base reactions. To assess the acidity and basicity of organic compounds, two of the most important theories are used. They are the Bronsted-Lowry theory and the Lewis theory. According to the Bronsted-Lowry acid-base definition, in a reaction a proton transfers between reactants. A Bronsted-Lowry acid is a proton donor. A Bronsted-Lowry base is a proton acceptor. The acid-base process, according to the Bronsted-Lowry theory, can be represented by the following scheme. Acid and base form a conjugated acid-base pair in which the stronger the acid, the weaker the conjugated base of it, and on the other hand, the stronger the base, the weaker its conjugate acid. According to the Lewis theory, acidic and basic properties of the compounds are determined by their ability to accept or give a pair of electrons to form a bond. Lewis acids could be an atom, a molecule, or a cation having a vacant orbital, capable of accepting a pair of electrons to form a covalent bond. Representatives of the Lewis acids are halides of elements of the second and third groups of the periodic system, metal cations, and a proton. Lewis acids participate as electrophilic reagents in heterolytic reactions. Lewis acids are acceptors of pair of electrons. A Lewis base is a donor of electron pairs. A Lewis base, an atom, molecule, or ion should have at least one pair of valence electrons and donate it to the partner to form a covalent bond. A Lewis acid-base reaction is the conversion of the lone pair and the empty orbital of the acid into a covalent bond between the acid and the base. The product of a Lewis acid-base reaction is a covalent bond between the acid and the base. Both bonding electrons come from the base, so it is a coordinate covalent bond. A curved arrow from the lone pair to the atom with the empty orbital is used to show that the lone pair will become the bonding pair between the two atoms.